So these notes are going over different types of matter, and we've gone over the states of matter, but these are going to be more specific than that. So find the empty notes in your notebook, and this will be the last new thing of Unit 1. So we're going to start with this picture, which is our very first type of matter. This type of matter is an element. And that is the most basic of our types of matter. An element is a substance that cannot be broken down into any other substance. It is the most basic type of matter. It is the simplest type of matter. An element is made up of only one kind of element, so it could be more than one atom stuck together as long as it's the same kind of element. So oxygen, O2, is two oxygen atoms connected, but it's still an element. And an element is something that can be found on the periodic table. So there are 118 known elements, and really that's also how we know if something is an element or is not. If it is on your periodic table, you can find it in your agenda, then it's an element. If it is not on that table, then it is not an element. So there are 118 known elements, but some examples are gold, and its abbreviation is AU, tin, its abbreviation is SN, aluminum's abbreviation is AL, carbon's abbreviation is C, oxygen is O, and hydrogen is H. When identifying an element, you are looking for a single capital letter. Every element on the periodic table has one capital letter, and then some of them, that's all they have, but some of them have a second lowercase letter. For instance, gold has a capital A, then a lowercase u. So anytime you're trying to distinguish if it is just one element or if it's more than one element, you are looking for a singular capital letter. Moving on to our next type of matter, we're going to get slightly more complex than an element. This type is a compound. And a compound is a substance made of two or more elements that are chemically combined. So they are put together chemically with chemical bonds. And when we talk about compounds, we have two different types of compounds. And we've talked about those already with our words worth knowing. But the two categories of compounds that we have are organic compounds, which are compounds that contain the element carbon, or inorganic compounds, meaning not organic, and those are the compounds that do not contain carbon. So we have a few examples. One of them is water, which is abbreviated H2O, that's pure water. Carbon dioxide is CO2. Carbon monoxide is just CO. Table salt is a common compound, that's NaCl. And sugar is also a good example of a compound, it's C6H12O6. Looking at these examples, I also want to go over inorganic and organic one more time, and just a common mistake that a lot of students make. So organic compounds have carbon, so we're looking for that capital C by itself. That's what stands for carbon. All right, a C plus a lowercase letter is not carbon, it would be another element. So like a Ca would be calcium, a C with a lowercase L is chlorine, like in table salt is sodium chlorine, NaCl. You will never see a capital C and a capital I next to each other. So if you see something that looks like Ci, it is almost definitely Cl, chlorine, and it is not carbon, so it is not an organic compound. So in our list of examples, water would be inorganic because there's no C for carbon. Carbon dioxide, CO2, is organic because there is a capital C for carbon. Carbon monoxide, CO, is organic because it has that capital C for carbon. Table salt, NaCl, is inorganic. The capital C in table salt is part of chlorine, not carbon. And sugar, C6H12O6, is organic because the capital C is for carbon. All right, moving on to the second half of the notes. This is the bottom half or the second page of your note sheet. We're going to start with the first of these two. Both of these are mixtures. The first type is a homogeneous mixture. A homogeneous mixture is two or more substances in the same place that are not chemically bonded, and they are uniform in composition. So a homogeneous mixture is a mixture. All right, that's just the fact that they are two or more substances not chemically bonded. But a homogeneous mixture is uniform in composition, and that just means that the whole mixture looks the same throughout. There are not pieces floating around, there are not different layers, it all looks the same. Another thing that is true about homogeneous mixtures and all mixtures is that it can be separated by a physical change. So both homogeneous mixtures and all mixtures can be separated by physical changes. Some examples of homogeneous mixtures are air. Remember, air is made up of nitrogen and oxygen and water vapor and lots of other gases. It's a mixture, but it all looks the same. It's uniform. You can't see the different gases, so it is a homogeneous mixture. Honey is also a homogeneous mixture. Soy sauce and coffee. They are all mixtures that are the same throughout. You cannot see the different pieces or parts that are mixed together. It all looks the same. And moving on to the very last one is the picture of the salad. And this one is another type of mixture. And this type of mixture is heterogeneous mixture. A heterogeneous mixture is a mixture, so it is two or more substances that are in the same place that are not chemically bonded. It can be separated by physical change, but it is also a mix of substances where you can easily see the different pieces. So you can see all of the parts put together, like a salad where you can see the lettuce and the tomatoes and the cucumbers and whatever else you have in it. A heterogeneous mixture can be easily separated, and it is not uniform in composition. So it is not the same throughout. There's pieces floating around, there are layers that have separated, there are lots of different things as part of the mixture. Some examples are salad, guacamole, trail mix, Italian dressing. One of the things that you can remember is if it settles, if you have to shake it up or stir it up, then it's a heterogeneous mixture. So things like Italian dressing, orange juice that settles, it's got separate layers, so it's a heterogeneous mixture if it naturally settles. Or if you can see the pieces. So those are how you can tell if something is a heterogeneous mixture.